D. W.D. Ashok Sir, Honorary Trustee, Seshadripuram Education Trust, for the occasion. Welcome you, sir.
Thank you, madam.
I also welcome B.A. Anantram Sir, Chairman, Governing Council Chairman, Seshadripuram Academy of Business Studies, and Trustee, Seshadripuram Education Trust, for this valedictory session. Welcome you, sir. I also take opportunity to welcome Professor Jaira Masa, who is the backbone of conducting such kind of a meticulous program, 10 days FDP, national level FDP through our institution. I also welcome Professor Jaira Masa for this occasion. Welcome you, sir.
Continue, ma'am.
I also take the opportunity to welcome all our colleagues who are contributing their effort to conduct such kind of a program. I also welcome Professor Shivkumar CS, who is a coordinator of a research cell, who is a pioneer of conducting such a wonderful event throughout a 10 days event. Welcome you, sir.
Thank you.
I also welcome all my dear teaching staff for the occasion. Not but not the least, without the participant, any program will not go to the higher heights. But from day one, we are having a statistic. From the day one, the participant list is more than 350, 400, and it reaches to 500 also. So thank you so much for your constant support, and I wholeheartedly welcome you all for this valedictory session. Once again, I welcome you all. Thank you.
Thank you, Soumya ma'am. On behalf of ACT and SABS, I welcome you, ma'am, for this program.
Thank you. Thank you so much. And I just want to take the opportunity to wish you all World Philosophers Day. Thank you. Happy Philosophers Day.
Thank you so much. Now I request Assistant Professor Rakshita ma'am, Department of Commerce and Management, to introduce the guest of today's session. Over to you, ma'am.
Nandini ma'am. Rakshita ma'am is not there. I'm disconnected. Nandini ma'am.
Sir.
Please.
Sir, Rakshita, why is there in the session? You can
No,
make her as a co-host.
Yes. I'm already I made it.
Yeah, she's there in the session.
Wait, ma'am.
Rakshita, why is there, sir?
Yes, Rakshita, why not? Yes, ma'am.
Rakshita ma'am.
Wait, ma'am. Rakshita ma'am.
Yes, sir. Thank you. Good evening, everyone. I'm very glad to introduce the resource person for the FDP, Dr. R. Kashilingam, sir. Sir is the professor of finance, business analytics, and business law. He also serves as a nodal officer for RTI and public grievance of the university for the past 3.5 years. He is a multi-talented academician with MBA, CMA, ACS, ML, MCA, MPhil, and PhD qualifications. Professor Kashilingam sir has a blend of industry and teaching experience spanning more than 3 decades. Sir has more than 183 research publications. He has produced 8 PhDs, completed 2 research projects funded by NHRC and ICSSR, evaluated more than 100 PhD theses, and serves in the reviewer panel of leading international journals. Sir has organized more than 30 plus data analysis and model building workshops, MDPs and FDPs, and has been a resource person to 138 plus workshops. Sir is serving as board of study members in colleges such as MS University and TNOU, to mention a few. He's also a member in more than half a dozen professional bodies such as MMA, TIES, etc., and is associated with TCS for academic initiatives. Sir is passionate about expanding and sharing his expertise to everyone. And now, on behalf of Sheshadripuram Education Trust and Sheshadripuram Academy of Business Studies, I would like to introduce the guest of honor for today's program, Shri B.A. Anantram Sir. Sir is Chairman, Governing Council of Sheshadripuram College. Sir is rendering impeccable service to SET and has always been a pillar for the progress. Sir has always been passionate and provides immense support and is a driving force at Sheshadripuram Academic Trust. He always strives for achievement and success. And now I would like to introduce our honorary trustee, Shri W.D. Ashok Sir. Sir holds master's degree in pharmacy, specialized in the field of total parenteral nutrition. He has served at the famous Aladdin Hospital, Kuwait, over 13 years. He is a trustee of Sheshadripuram Educational Trust. Sir is the backbone for all the events conducted in our college, and his constant support has aided us to achieve greater success. Thank you.
Thank you, Rakshita ma'am, for your gracious introduction. Knowledge is an investment which always pays our best interest. In this motto, we had organized this FDP, and from since 9 days, everyone have been benefited by this FDP. I request few of the participants to share their experience, their opinion by unmuting themselves. Any participants can raise their hands, so you'll be provided the chance to share your opinion.
I request Kailasapati sir, please sir.
Sir, I take this opportunity to express my sincere gratitude for attending such a wonderful FDP for 10 days. Sir, it is indeed a great pleasure for us. We have attended so many FDP so far. I never come across such a FDP in my life. Really, we learned a lifelong experience, sir. Many FDP they conduct formally. We have experienced such a such a beautiful resource person we have brought from the Pondicherry University, sir. I'm really happy to have such a real God man to teach that SPSS, sir. Sir, thanks to our committee organizer and resource person for gracing us with a beautiful knowledge, sir. I'm really, I have become a habituate, sir. Every day I used to sit, even though I'm a principal of government degree college, I have got so many work, but I don't know, when it starts at 6 o'clock sharply, I used to sit in front of this computer to every day watch these things, sir. From tomorrow onwards, we will miss this FDP. Really a great thing, sir. Sir, in future also, if you conduct such type of FDP, please inform me, sir. Sir, thank you, Shukumar, sir, and your team for giving me this opportunity, sir. Thank you for even especially thanks to our resource person, Kashilingam, sir. Sir, thank you, sir, wherever you are, sir. Thank you, sir. Thank you for giving me such a opportunity.
Thank you so much, sir. Thank you.
Okay, Ammani Shivaram, sir, 3 members.
Good evening, sir. I am Ammani Shivaram, Head Department of Mathematics, Kumarani Meenamuthiya College of Arts and Science, Adyar, Chennai. I really congratulate the organizers for having conducted this FDP in a smooth manner, and congratulate them also on finding a beautiful and wonderful resource person. Dr. Kashilingam, sir, hats off to you. I have attended SPSS workshops earlier, and we had practical sessions also. But I should say, sir, nobody has explained SPSS so beautifully, so wonderfully, and also with really good examples. The examples that you gave really were hilarious and also made us understand the concept very well. Thank you very much, sir. And also the organizers, a wonderful job. Hoping to attend such more FDPs in the future. Thank you once again.
Surya, ma'am.
Can you hear me, sir?
Yes, ma'am.
Okay. My name is Surya and I am from Kerala, sir. First of all, let me thank Sheshadripuram Academy of Business Studies for conducting this FTP on SPSS with this extraordinary genius resource person, Dr. Kashlingam, sir. The entire session was highly effective and excellent. I literally thank organizers for conducting this FTP. At this very moment, I really wish to say the excellence of a resource person. The way the sessions were handled with interesting examples and a friendly approach, a lot of tough concepts in statistics, such as factorial ANOVA, regression, and yes, dummy variable regression, were taught so effectively, or even explaining the concepts behind the things like the concept behind the degrees of freedom with 22 matrix as an example are like very effective and informative. And I must say, even though I have seen or heard the word degree of freedom several times before, but I never know the concept behind it. I just know the word and the formula for it. And it is for the first time through this FTP I have come to understand the real concept behind the degree of freedom. And the sessions were excellent, sir, brilliant. Wholeheartedly, I thank Dr. Kashlingam, sir, also Shivakumar, sir, Nandini ma'am, and Rohini ma'am also, Soumya ma'am, for effective coordination and interaction. And also, I thank everyone who take part in the organizing and coordination of this FTP and giving us a chance to learn new things. Thank you so much.
Okay. Rohini ma'am,
Thank you.
continue ma'am. Rohini ma'am, enough. We can call it lost ma'am. Rohini ma'am. Rohini ma'am.
Sir. So can you hear me, sir?
Yes ma'am, continue
Yes.
the session. We can lost.
Okay, sir. Now I request Ashok, sir, honorary trustee, to address the gathering. Over to you, sir.
Thank you, madam. A very good
Thank you.
evening to one and all. From Sheshadripuram Academy of Business Studies, this quality session from IQAC cell, research cell, and Department of Commerce and Management in association with Bangalore University Teachers Council of Commerce and Management, that is BUTCOM, has gone wonderfully well from the past 9 days. And this is the 10th day session, the last day. It has, as the feedback has come from the participant, I would like to thank the resource person, wonderful person who has given from the fundamentals to the complete PhD levels of thinking. I would like to thank Dr. R. Kashilingam, sir, professor from Pondicherry University. And I would like to thank from the beginning, that is the inauguration session, which was started from the day one, which was inaugurated by our secretary, Dr. Uday P. Krishna. The same, I would like to say that the fundamentals from the beginning, the data analysis and SPSS, which went from day one, how the advancement in the computing technology has further raised the importance of data analysis and placed great demand on its application to complex decisions-making process with the availability of various data analytical techniques and user-friendly softwares such as SPSS, which sir has
Sir, mute ಆಗಿದೆ. ಶಿವಕುಮಾರ್
Ashok
sir.
sir. Ashok sir.
Mute ஆயிருக்கு sir.
Ashok sir.
yeah, sir.
Okay. sir.
Sorry for the interruption. I was just saying that whatever the advancements in the technology has taken place, the ability to analyze large data has not only become simple, but at the same time for academicians and intermediate researchers, these sessions went on very well. This program has addressed issues in theoretical and practical inputs from our resource person. This program has emphasized on the techniques available in the research methods and also multiple regressions or multiple dimension scalings, statistical analysis, whatever was necessary, sir has explained from the level of students to even the academic holders. And also he has given the fundamentals how to make the data meaningful, how to integrate individual files, how to prove your research papers, principal components of analysis, and also whatever the cluster analysis he has wonderfully said. And I would like to say, even for new people who have not been exposed to SPSS, he has made it into a very simple sessions in his day-to-day sessions. I would like to once again thank him for all the day-to-day sessions and his wonderful caliber of explanations. Wherever the quantitative methods or qualitative methods, whatever it is, he has explained it in a wonderful way. And I would like to say that he has given from whatever the types of data are there or variables are there, he has explained it from very, very fundamental viewpoints. And on the whole, this program has gone wonderfully. And even from the way the participants have today explained or given their wholehearted feelings that how the program and how Kashilingam sir has given them the feedbacks, wonderful it is. I would like to thank the coordinator, Shivkumar sir, and also our from the Department of SOBS, that is Somya madam and Rakshita madam, and thanking Jairam sir for all these wonderful programs which he is conducting and bringing up the academic level of the students as well as academicians. I would like once again to thank all the participants in today's program. A wonderful evening to one and all. Thank you.
Thank you, sir. Thank you. Pleasure, sir.
Thank you.
Thank you so much, sir, for your gracious appreciation. We are overwhelmed by your words, sir. We have reached to the end of the
Shivkumar sir, you
formal
can continue.
validation.
Yes, sir. What, sir?
Have
Yes, sir.
reached to the
It's continuing, sir.
We have reached to the end of formal valedictory session. Let us not assume that it is as a end. We will always research for the knowledge enhancement continuously. Now I request Assistant Professor Nandini ma'am, Department of Commerce and Management, to present the vote of thanks. Over to you, ma'am.
Okay, ma'am. Never stop learning because life never stop teaching. A very good evening to one and all. I am Nandini Archi, Assistant Professor, Department of Commerce and Management. It gives me an immense pleasure to propose a vote of thanks on behalf of Seshadripuram Educational Trust, Seshadripuram Academy of Business Studies for this informative 10 days national level virtual faculty development program. The capacity to learn is a gift. The ability to learn is a skill. The willingness to learn is a choice. I thank PUT-CCM for associating with us to conduct such a meaningful program. Firstly, I'd like to thank our resource person, Dr. R. Kasilingam sir, Professor, Pondicherry University. Thank you so much, sir, for wonderful session. Each session made us to gain knowledge towards SPSS, which is more inevitable for all the research scholars and teachers fraternity. Thank you so much, sir. I also thank WD Ashok sir, Honorary Trustee, for constant encouragement to organize this program. Thank you, sir.
Thank you, madam. Thank you, one and all.
I thank today's guest of honor of the program, B.A. Anantram sir, Chairman, Governing Council, for his continuous support. Thank you, sir. I would like to thank our principal, Professor Jairam sir, for his support to organize this program.
Thank you, madam.
Thank you, sir. I also thank Program Coordinator Shivkumar CS sir for organizing this knowledge enrichment program. Thank you, sir.
Thank you, ma'am.
I also thank IQAC Coordinator Dr. Chetana ma'am and HOD and Soumya DN ma'am, HOD Department of Commerce and Management.
Thank you, ma'am.
I would like to thank all the participants for your active participation and making this program successful one. Once again, I thank everyone who is directly, indirectly supported for making this program successful. Thank you.
Thank you, Nandini ma'am. Now I request our resource person, Dr. Kasalingam sir, to take over the session. Over to you, sir.
Thank you, madam. Thank you. So, yeah. So now, see, everybody, they are talking about the examples. So the examples are reaching, I think, good way. So before I could go to the logistic regression, so let me give one example to so I think this screen we were talking yesterday, right? Which is about normal distribution, right? So I will give one example for normal distribution. See, for example, Sivakumar sir might be knowing this example. So we used to conduct a physical workshop, all right? That time I used to ask, if at all here, the department is here. So if you go outside, there is a one small temple is there, right? So I used to ask one gentleman, if I ask you to go from here to that temple, if you come back, how much time you will take? He will tell, sir, probably half an hour I will take, sir, right? Then one day you have taken half an hour, then after 2 hours. So if I ask you to walk again to that place and come back, how much time you will take? You might say 31 minutes, right? Then next day morning, what I will take 29 minutes, right? So like that. Now, let us presume that I have asked that boy to walk 100 times, right? Not one particular day, over a period of time, 100 times, right? So I have recorded, right? Sometimes he might have taken 30, 29, 31 minutes, 32 minutes, 33 minutes, like that, right? So whatever time taken, it is recorded, right? In a one column, which is now it since it is minutes, it is a metric variable. For that variable, I have taken a average, right? Mean. Then I have taken a standard deviation, right? So my mean, okay. So my mean is, let us assume that mean is 30, right? So my mean is I'm going to use one more, probably you are all teachers, you might be knowing, right? So I'll use that also, right? So now, right. So my mean, right? So mean equal to 30, right? Let me put in color also, let me put white. So the mean equal to 30, mean equal to, okay, 30. Okay, then the standard deviation is 1, right? So now, now what happens? Now what happens? So now, okay, so now, for example, now what happens? Mean, right? Mean. So that is mean. So let me take. So now mean, right? Which is so many screen in between. What to do? right? So the mean, which is 30, is not writing. Let me write. Okay. So mean 30, right? Plus or minus 1 standard deviation, which is 1, right? Plus or minus 1. So which means 29 to 31 minutes, right? If I take, you know that maximum time he might have taken 30, right? So he might have taken sometimes 31 also, sometimes 29 also, right? So now if I count how many times he has taken 29 and 30 and 31, now it says this will be 68 times, right? So out of 100. So suppose if I take 28, which means 232, right? Which means mean plus or minus 2 standard deviation, right? Mean is 30, this side 2, this side 2, right? So now if I take 28, how many times, 29, how many times, and okay, so if I calculate that, so now okay, so that will be, okay, that will be 95 times, 95 times, right? Suppose if I take 27 to 33, 27, 28, 30, 31, 32, 33, then 99 times we may cover, 99 times we will cover, right? So normally it will go like this. Normally, so middle he will take more number of times. When you come this side and this side, you'll go lesser, because 31 little lesser, 27 it will be little more lesser, right? Because normally it will take 30. Sometimes, see, we cannot say we are not machines walk straight away, right? So these deviations are bound to happen. The deviations are bound to happen, right? So, but more number of times on the middle, a little lesser number this side, little. So that is why we say the curve will be like this. Then what is this 1%, sir? What is this 1%, sir? Right? See, what will happen is one day, see, that is we have conducted, Sivakumar sir has conducted on Sunday also, right? So the Sunday, here that gentleman has prefixed some appointment with somebody, right? But Sivakumar sir said, no, if you are not coming, no certificate. So he has come, right? So then before he could come, he has told that person, right? That person. So because he has fixed a program with that person, no, see, the program will get over by 8 o'clock. So I will come immediately. As soon as it is over, I will come. Okay, so wait. So then, okay, so he is thinking that in the mind, though he is sitting in the class, he is thinking that in mind. Now that also I have asked him to walk, right? He is moving, he has gone to the out of the gate and he was walking the road. When he was walking on the road, on the other side of the road, he has seen somebody. He has seen somebody, right? Nandini madam, who is that person, madam? Hello, madam, who is that person? Okay, so she is that person, right? He has asked, so he could not believe. Like, how come this person I've asked to do? So then what happened? He has ran and he has jumped in the center median, gone to the other side. He was like, who you have come? I don't know, how did you come? He was talking like this. He was going on talking. Then he said, no, you please wait here itself in the bus stand itself. So I will go and I will report and I will come. So he has come back. Now, how much time he has taken now? And then, madam, how much time he has taken? Nandini madam not there. How much time probably he might have taken? He might have taken more than not 32, 33. He might have taken 45 minutes, right? So is it acceptable behavior? Is it a normal behavior? Is it a normal behavior? No, it is not normal behavior. So this kind of behavior also bound to be there. So this kind of behavior we have to reject, right? So that is why these are all bound to happen. Okay. So that is why it will be like this, right? So see, when you operate with the 2 standard deviation, if it is less than here, if it is less than this, if it is within this one, we are going to accept. If it is beyond, if it is 45, we are going to reject. Why we are rejecting? It is not due to the chance, right? So the deviations are happening because of chance, because of in normal circumstances, all bound to happen. But this has happened because he has seen that girl. He has seen that girl. That is why he has taken more time. So this is not a normal behavior. This is an extraordinary situation. For a delay, there is a reason that has to be rejected. Okay, so that is what. So when it is beyond a certain, okay, beyond the certain level, we are rejecting. We are rejecting, right? So the some difference will be within the range. So the difference within 1.96 this side, it is bound to happen. But if it is beyond that, okay, there is a reason. So probably they are using more cell phone. That is why the usage is more. So we are rejecting. So this is the normal. Okay, so it is not something different. Normally is normal circumstances. Normally, what will happen? Normally, what will happen? That is the normal. When you put the data, how the data will be distributed. That is called the normal distribution. Normal distribution. So this theorem 68%, sir, how you are telling, sir? Somebody, they have done a research many times and they have reported. So this theorem, we call it a Sebisu theorem. This theorem, we call it a Sebisu theorem. That theorem says mean plus 1 standard deviation, this side 68. 2 standard deviation this side 95 and 3 standard deviation, right? So this is what one example, right? Seeing a girl, taking more time, all these things are going to happen, right? So now we will go to the logistic regression, right? Okay, so I think it is visible. It is visible. Very good. So I think this screen is visible, right? So carefully, please watch. It is a little difficult, but very easily I can tell. But you understand why it is happening, then you will be more happy, right? So first of all, this you should not forget. This you should not forget. Okay. So now our dependent variable is category, binary, 0 and 1. So my independent variable may be category and metric, right? So no normality assumption. So dependent variable is converted into probability. So which is again converted into odds. Odds is nothing but probability of occurrence divided by probability of not occurrence. So the occurrence may be anything, right? Probability of getting a seat and the probability of not getting a seat. Probability of 1 person smoking, probability of not smoking. So the probability of having own house, probability of not having own house, right? So the probability of understanding, yes, understood instead of asking understood, not understood. So probability of understanding all this, right? So now, okay, so now this is called the odds ratio. This is called the odds ratio, right? So this is called the odds that you should not forget, right? So this is called the odds ratio. So the word odds you should not forget. So now, see now this probability of this bird odds that you should not forget. Okay. Then okay, so then log log of odds, log of odds. So that is why it is called logic. So my dependent variable is logic. That is why it is called logistic regression, right? That is why it is called logistic regression, right? So now the odds equal to odds, right? So this is a odds, this is a odds. So my odds equal to so this is my odds, right? So my odds equal to so now my odds. So my odds, this is my odds. Odds equal to E of, right? E of, right? So when you want to remove this E, when you want to remove this E exponential, when you take log this side, when you take log this side, right? So when you take log on both sides, when you take log on both sides, so this will become log, this E will be removed. So my logic equal to, okay, A plus Bx. Normally this is our regression equation. So my dependent variable is logic. So yeah, is that right? So so odds is probability of occurrence divided by probability of not occurrence. So why I say probability of not occurrence? 1 minus probability of occurrence is the probability of not occurrence, right? So now the point is odds is equal to e to the power a plus bx, that you need to, right? When you take logic, which is equal to a plus bx, that okay. So that one thing you should not forget. Then the probability equal to odds divided by 1 plus odd. So P probability is equal to odds is e to the power a plus bx, 1 plus e to the power a plus bx. These are all I have already explained. Why I am taking odds, that also I have already explained, right? So now, okay. So now, first, right? So first of all, okay. So only 2 sentences, right? Only 2 sentences. But to explain that 2 sentences, I'm going to tell many things, right? Only 2 sentences, right? So, okay. So even if you are not understanding, no worry, that finally I will tell which 2 sentences you need to know very, very importantly, right? So now let me take the data set. Let me take the data set. Okay. So is it visible, sir? Nandini madam.
Sir, yes, sir, it is visible, sir.
Yes, sir, visible.
Madam, enna madam, where did you go, madam? Nandini madam, what is this, madam?
Sir.
Okay, so now, so my dependent variable is, okay, so this is my dependent variable, right? So now dependent variable is having, madam, dependent variable is having 2 category, right?
Yes, sir.
One is admission, right? Admitted, another is not admitted, right? So now the okay, so whether you got a seat in foreign country, right? That is the idea, right? So whether we have a seat in a foreign country or not, right? So admitted or not, I want to know whether I will get a seat in that Harvard University, like that, right? So now what are the 3 variables I have taken is GRE score, right? Okay, your the GRE score, your score, and the your grade, and the rank of the institutions in which you are studied, right? So here I have not put a category, but it is a category variable, 4 ranks, right? 4 ranks. So this is a categorical variable with the 2 binary. So this is 2 are metric variable. This is my category variable. Rank is my category variable. You can see rank is my category variable, right? So now before now I explained what are the variables, right? Madam, explain what are the variables I have taken, madam?
Sir, 2 category variable, 2 metrics, sir.
No. What are the variable? Getting admission.
Admission, not non-admission.
Then GRE score means your own individual GRE score and their grade pass. And what is the institutions in which they have studied rank, right? So the institutions are divided into 4 ranks. So what is this one, right? Very good. Now, right. So now, first of all, let me take a frequency analysis for a categorical variable rank admission, right? Which is my dependent variable, which is a binary. Binary means 0 and 1. Yes or no, madam? What is binary, madam?
0 and 1, sir.
Very good, madam. So now let me put admission here. Let me put a frequency, right? So it's not a statistic. Why is unnecessarily statistics? Right. So now, right now, okay. So now, how many people not admitted? How many people not admitted, madam?
27.3.
No, how many people?
People.
273 people.
Yes, sir. Yes, sir. Yes, sir.
273 people not admitted, 127 people admitted. So what is the percentage of not admitted people? 68.3. Please remember in the memory, right? 68.3 is a not admitted, right? Very good. So now you know this one, right? Now. Okay, so now you know this one. Okay. Now let me perform a binary logistic regression, right? Analyze regression, binary logistics, binary logistic regression, right? So I put okay. So I will cancel all. Already it is there. So now regression,
Binary logistics.
binary logistics. My dependent variable is, madam, what is my dependent variable?
Admit.
Admit, right? Madam, please be here, madam. Okay, my dependent variable is admit, right? Right. Now let me take one by one so that my explanation will be easy. Now let me take one variable, right? One variable. One variable here, right? One variable here. So which is a rank. Now I know that it is a category variable, right? I know that it is my category variable, right? Then I have to tell, right? For category variable, we cannot perform regression. Okay. We have to perform dummy variable regression, right? So when there are 4 category, it will create a 3 dummy, right? So we are not going to create, it will create, right? So, but I need to tell it is a category variable. So here categorical, right? I'll put this one, right? Now here you can see, right? In a categorical variable, right? So one variable will be a dummy, right? One variable will be a dummy, right? So what is that variable which is dummy is, you can see here, the reference category. The reference category is last category is considered as reference category. But if you want to say first one, you can do, no problem, right? So now let us take last, that is the rank 4, okay? Rank 4 institution, right? So that is the reference category. That is the reference category, right? Okay, so now, right, done. Okay, done. Right. So now let me go one by one output. Let me go one by now. I performed a binary logistic regression, okay, by taking rank, which is a dummy variable, right? Very good. Okay. So now, okay, so the sample size is 400, right? So that all thing you really remember, right? How many, right? Let me note it down. Madam might forget, madam may not tell, right? So how many, right? So how many is my admission? How many is my admission? So
Sir, admission
273, not admitted 273, and
Admitted is
admitted is
127.
127. So totally 400, right? So that is what I know. So now that is what it is telling, right? So you have taken up 400 samples, are no missing cases. So that is the first table, which is not more relevant to us, right? That is number one. Number two, right? Number two, right? Now my dependent variable is not admitted 0, admitted 1. That also I know. Now I have taken one category variable, right? One category variable, right? So which is the rank, right? So which is having 4 category, right? So first category for rank 1, right? See here 1. All other things it has put to 0. All right. So 61 people are there in first category. That is the first rank. So second rank, okay, let's see, 3 variables are created. What is the second variable? Second variable with rank 2 is a second variable, right? Dummy for second variable. Third variable is rank 3 is considered as this one. So rank 4, all 3 0, which means he is not first category, he is not second category, he is not third category, which means when he is not there in all 3 category, it is presumed that he is the 4th category, which is considered as reference category, right? So now you have to remember what we have studied when we use a dummy variable, right? Okay, so that I will come later. So now here, right? Now here, what is this table?
Sir.
Okay. So now, what is this table, right? One by one, I should go. Now this table, right? So this is the classification table, right? So now, okay, what it says. So 273 not admitted, 127 admitted, right? Okay, fine. Now, okay, now, right? So in the beginning, right? In the beginning, okay, how it will perform is, right? Without considering any variable, right? Just close your eyes. Don't use any variable. That is the beginning, right? You say everybody not admitted, right? 0. Everybody not admitted, 0. Right? You need, for which you need not use any variable, right? Right? You should not consider anything. Now closing your eyes and you say, hey, all are not admitted. Yeah, go. If you say, if you predict like that, then, right, what extent, then also even by closing eyes, everybody is not admitted category, then also you will be right at a 63.3%, 68.3%. Because, see, now you are putting everybody not admitted. See here, everybody not admitted. Then if you put like that, 273 people, you will be right? Because they are not admitted. Now also you say not admitted. It will be right 273. But 127 wrong. Because they are admitted. But now you say everybody not admitted. Then 127 wrong, 273 right. Okay. So now what you are doing? You are not calculating, you are not predicting, you just say everybody not admitted. Even if you say like that, you will be right to the extent of 68.3%. How? Out of 400 people, 273 people not admitted. Now you also say not admitted, which means that is a rightly you have done. Right? So without using any variable, without using any independent variable, right? Independent variables are 0, right? So your intercept is, right, 68.3%, right? So you are right to the extent of 68.3%, right? Now, okay, so now this is my, okay, so now this is my beta, right? What beta? Constant intercept, right? Because in the variable in the equation, we are not taking any variable first in the beginning. We are not taking any variable, right? We are not considering any variable, right? That time itself, so the my beta is 0.765, right? Minus 0.765, right? So now, right? Now, right? So now you take exponential, right? E to the power beta, right? E to the power beta. So which means e to the power minus 0.765. Then if you find out, if you, by using calculator, if you find out e to the power minus 0.765, then you will get 0.465. That is exponential of a plus bx, right? Now I do not have bx, I have a, right? Okay, so exponential of a is this much. What is exponential? Which is odds. Which is odd, right? So what is odd? Probability divided by 1 minus probability, which is equal to e to the power a plus bx, right? So that is the odd, right? Now this is this one, right? So now, right, I say this is odd. This is odd. What is odd? Odd is probability of getting a seat divided by probability of not getting a seat, right? Yes or no?
Yes.
Right. So what is the probability of getting a seat? Right. Probability of getting a seat. Right. Probability of getting a seat, how much? Right. So now, probability of getting a seat. Right. So now, okay, this we have seen, right? So 273, right? So out of 400, right? Okay. Right. So now, see the what is the right probability of getting admission is, right? Now what is the getting admission? 127. Yes, sir. See 127, right? We have not used any variable, right? So what is the 1 minus not getting admission, which means not admitted? Yes or no? 1 minus admitted is not admitted. Am I right, madam? Hello? Hello?
Sir,
Okay. Hello, madam? Any problem?
Sir, voice breaker.
My voice is breaking.
No, sir, not now.
Okay. So now the number of people admitted is 127. Okay. Probability of getting admission is 127. Right? Divided by 1 minus probability of getting admission, which means not getting admission. So 127 divided by 273. That is my odds. P minus 1 minus P. Now, which is equal to 0.465. That is this one, right? So that is why I say that is odds, right? Exponential, right? Right. So we said when you take exponential of beta, that will give odd. Now see here, right? What is odd? Probability divided by 1 minus probability. So admission divided by not admission, which is equal to, right, 127 divided by this one. If you find out this is 0.465, that is this value. Okay, that is what now. Okay, sir, you might say that, sir, you have taken, I think, some other value, sir, right? Okay, see here 0.465. Right. So now this is exponential of beta, E of beta. So this is beta, this is E of beta. E of beta is exponential beta, which is odds, right? Okay, so odds is P divided by 1 minus P, right? So this we have seen, right? This we have seen, right? So now, okay. So now what is this one? Omnibus test of model coefficient, right? So now this. So now all along without taking any variable, right? See block 0, right? Block 0 means we have not considered any data, just intercept. We have not considered any x, right? So now we are considering one variable which is a rank. We are considering one variable which is a rank, right? That is the block 1. So when you consider the one variable, right? Now I want to know whether my prediction has improved, right? All right. So now my null hypothesis is prediction is not improved. Okay. So my null hypothesis prediction not improved. So now we are trying to find out whether prediction has improved. Earlier point 68.3, right? So without doing any variable 68.3. Now my prediction has improved or not, right? So now which means 0.00, which means
Prediction improved.
Yes, madam.
Prediction improved, sir.
Yes, madam.
When it is 0.000 less than
which means reject the null hypothesis, which means
yes,
okay. So not improved is rejected, which means it has improved, right? So my prediction has improved, right? So now I am happy, right? So by using one variable, when I predict whether they will get admission or not, okay, I can predict, okay, it will improve. Yeah, that is what the first table, right? So that table over, okay. So it is written, right? So now, okay, now see here, right? It is 25, okay. So high square value is 25.010, right? Okay. So now this is the value I got. This is the value I got, right? So now, right? Now this is a high square test, right? Now let me perform a high square test, right? So now let me perform a high square test, right? I will see whether I am getting that value. Descriptive. Okay, madam, high square test, how to perform? Nandini, madam. Descriptive statistics, cross tab, right? Right, admission, and okay, so rank, right? Rank into
cross tab,
right. Okay. So now statistics, right? C square, right?
I square.
Now, okay. Now, see, you can see high square value, right? Right. Now, log likelihood ratio is 25.010, right? So now we are learning another high square. So the log likelihood high square, right? It is used when we use this high square for model building, testing the model, right? So testing whether the prediction has improved, the model building. So this is the high square. So we know that high square is used for 3 purposes. This is another purpose. So log likelihood, right? Likelihood ratio is used to find out the model fit, right? So when this is significant, which means model is fit. So we are adequately predicting. We are prediction has sufficiently improved, right? Very good. Sufficiently improved, right? Very good, right? How much improved? 25.10, right? Very good. We will see, right? 20, this much level, it is improved, right? Very good. 25, right? Now see here, okay. So now this is, we have performed, okay. Now we see what is the result we got here, right? See here, same value, right? Same value, right? So which means it is performing high square and it is telling. So this is over, right? So now what is this? Log likelihood minus 2 log likelihood, right? So now this is the worstness of it, right? Worstness of it, it should be lesser and lesser, right? it should be lesser and lesser, right? So now, if you predict, right, if you have predicted the model without using any variable, it should be lesser and lesser, right? Lesser and lesser, right? Right. So it is reduced, right? Okay, anybody, can you react what is here, how it will link? Okay, I will tell. Now, see, if you are not included, your log likelihood is, right, 474 plus 25.01, right? So which means 9, right? 9. Okay, so 499, right? 499, approximately 500, right? So now when you have not used any variable, my log likelihood worstness of it was 500. So now by including one variable, my log likelihood has come down by 25.010. Okay, so when I take one more variable, I can demonstrate right that time. Now, okay, so what is the likelihood ratio? Now you take one more variable, that time you will get high square. So to that extent, this log likelihood ratio value will come down, right? The worstness has come down. Worstness is coming down. What extent it is coming down, which means the prediction. That is the prediction. That is the high square value. That is the high square value. So now this is over. So this is R square, right? R square and this one. So this is R value, R square value. So now, okay, so this, yeah. Okay, so this interpreted as like R square in multiple regression. But okay, so Cox and null, it is like okay, it cannot reach a maximum value of 1, not reach, but Nagelkare, it can reach the maximum value of 1. So okay, so now normally, okay, this is both are R square, but okay, but we can tell the R square will range from this to this, right? We can tell my R square will range from this to this. Okay, but though it is very less, so you need not worry about it, right? R square is very less, you need not worry about it because log likelihood is significantly reduced, right? Right. Now, right. So now let me go to the output. Okay, so this we have seen, right? This we have seen. Right. Now classification table, right? Now this classification table, right? Now, see now what happened. Now this is very easy. Okay. If I explain only, you might be, now you may not understand, but when you look at it, you will understand, right? Now we have used earlier, we said everybody not admitted. We have become right to the extent of 68.3. Now we have used one variable, right? By using that one variable, now what happened? Okay, now what happened? So right, not admitted. So 245 right, 245 right. This admitted. This is also right. Okay, so observed also admitted by using that. Okay, so this also 33. So which means 245 plus 33. Okay, so which is 8, 7, 278 right out of 400, right? So now how much we are right? Not admitted 245, admitted 33. So if you calculate total is 278 right out of 400. So which is 69.5%. Right. So now, sir, how sir? Now let me demonstrate to you. Okay, let me demonstrate to you by using that equation. Slowly come with me, right? Not necessary certain things, okay, but I'm demonstrating everything. So now what we will do is we will save 23 people are waiting. We will save. So what we will save? Okay, so we will save the group membership, right? Predicted group membership, right? Then we will get one. We will get this one, right? Okay, we are getting. So this is the membership, right? This is the whether they are admitted or not, right? So, but now as per prediction, as per by using the equation, our predicted value is this one, right? So now the second person, see, first person not admitted, here also not admitted. Second person wrong, admitted, actually admitted, but this one, right? Now let us put the cross tabulation for this one. So crossed. So now so this is my predicted values, right? So this is my actual, this is my predicted, right? So now we will see. Right? So now, okay, this is what the table we have seen, right? This is what the table we have seen, right? So now admitted. Okay, so this is what cross tabulation. It is showing the cross tabulation table, right? So okay, out of 273 people not admitted, 244, right? So out of 127, 33 right? So when you find out a percentage, okay, so we can find out the percentage also, column percentage, so how much we will put the column percentage. Okay, very good. So we can say 278, how much divided by 400, we can find out how much, right? Okay, so we can find out, right? So 245 plus 33, 278, right, out of 400, which is 69.5. That is what it is telling, right? That is over that table, right? So now let us go to the another table. Right. So these are all very easy table. The one important table I will come. That is the most important table. Right. This I have explained. Right. So now this is what the most important table. Right. This is what the most important table variable in the equation. Right. So this I will take a little longer time, but before going there, so right. So this also, by using this one, right? Observed this one. We use in the machine learning language, we use certain words, right? Same table, right? Same table, 245, 95, 28, 33, same table. But I'm using some other words, right? Out of the admission, right? Out of the 127 people really admitted, right? 93, wrongly we said 33, right? So totally 127 people admitted. Out of that, we know that 127 people are admitted, right? So see, out of that, we are correctly predicted 33 admitted. So 33, that is rightly predicted out of total admitted. So which is equal to 0.26. That is called the sensitivity. What is sensitivity? Right admission divided by total admission. Right. Both positive. Admission, right? 1, 1, right? So what is specificity? Right. So not admitted, total not admitted, right? So totally as per observed 273 not admitted, right? but we have predicted 245 right. 245 right. So 245 right out of the total not 245 not admitted rightly predicted divided by total not admitted. So which is equal to 0.897. That is called a specificity. That is called a specificity. So this is a specificity. This is a sensitivity, right? This is specificity. This is sensitivity. False positive, right? Positive but false, right? So now, so in the admitted, right, out of this 61, so okay, so 61 out of this 61. So okay, 33 rightly predicted that we have come. So to this one, right? So in the prediction, we have predicted 61 as a prediction, right? Okay, we have predicted, right? So the top is predicted. This is a predicted, this is actual. So we have predicted 61 as admitted, but right is 33. But how much false? 28, right? So positive admitted as per our this one 61, right? How much false? So false positive admission. What is total admission predicted? False positive. So now that is 0.499. That is called false positive. False negative, right? So out of the total predicted 273. So okay, so total here, right? Total not admitted. In the total not admitted, that is what we have predicted. Total not admitted predicted is 33, in which wrong prediction is 94. 94 out of, okay, wrong prediction, false. Both are false, wrong. This is also wrong, this is also wrong. This is both right, predicted right, right? So admitted predicted right, not admitted right. This is false. So 94 is false, admitted, not admitted, right? So false divided by 339, that is called false negative, right? How much is right? Okay, that is called accuracy. So 23, 245, right? 23, 278 divided by this one, which is equal to 0.69, 69.5. That is called accuracy. Some words they will be using, right? This is even doctors, everybody, they are using these words: sensitivity, specificity, false positive, false negative, right? Okay, okay. So now, okay. Now I'm going to explain. Okay, I'm going to explain this table, right? This table is the most important table where you write. Okay, all other things not important. Yeah. Okay, so what are the things we will see? First, we will look at whether we have sufficiently predicted. So by looking at omnibus, okay. So the model is right based on chi-square. We will see what is the how much rightly predicted. 69.5 is the rightly predicted. So okay, so other things, principality, all these things, if you want write, you can write. Otherwise, not necessary, right? So our log like the R square value is this one. So this is what we will report. So these are all you will write one sentences. You can put everything in one table. You can write, but this table is very, very important. So now you can note down. Okay, I'm going to be SPSS. So that is the PowerPoint, and I will explain. Right. So now the for rank, this is the beta. Right. This is my beta. Rank 1. Right. So now. Okay, you need to remember it is a dummy variable I'm using, right? So this is when how to write. So rank 1 is this much more that we will write, but here we will be using different words. But you have to write based comparing with the rank 4, right? With the reference category. So we already see. So that person is 25 rupees more than this population that we have seen. The same thing. But okay, so we will use the different word. What is that different word? Okay, so first of all, right, one thing you need to know, right? What is that one thing? Right. So first of all, now, so this is the beta. This is the exponential beta, right? E, right, exponential, right? When the beta is 0, when the beta is 0, right? When the beta is 0, my exponential of 0, right? Okay, so now I will write. Okay, so I will start writing. So let us see whether I am writing right. So my, see, for example, my beta, right? Okay, so when my beta, okay, right, when my beta is 0, so exponential of beta. So otherwise exponential of 0 is 1. That you need to know, first point, right? Exponential of 0 is 1, right? That is the first point you need to know, right? So that now suppose, all right, now, okay, now my beta is negative. My beta is negative. What does it mean? Right? See, in the regular recursion, beta is negative. What does it mean? Right? When x increases by 1, y will decrease. Y will decrease. That is the negative beta, right? What is negative beta? Please understand. When my x is, what is beta? When there is a 1 unit increase in x, what is the unit increase in y? My beta is negative. My x increases by 1, y will decrease by that extent of beta, right? So that is a negative beta. But here, for example, my beta is negative, right? Negative. So exponential of negative is less than 1. That will be point. That will be point. So now you can see here, right? So here it is negative. So exponential of negative is point, right? So suppose my beta is equal to positive, right? Some positive value. Then exponential of positive value will be equal to greater than 1. So now you can see. Now this is positive value, here greater than 1. Right? So now you have to write it down. My beta is 0. My exponential of 0 is 1. My beta is negative. My exponential of negative will be less than 1. Right? My beta is positive. My exponential of this one is greater than 1. Right? Very good. Yeah. This is 1 point. Okay. This is general, right? It is not here. That is normal. Anybody should know. Anybody should know. That is general. Okay. If you take by using calculator, if you find out, you will get, right? That is number 1. Okay. So now I hope that you have, okay. So now I hope you might have understood this point, right? So now now I'm going to tell important point here, that other things not necessary. Yeah? This now whatever I'm going to tell, that is very important, right? So now, right? Now, when my beta, see, now one more thing I will write, right? So now, if I say 5 into 2, which is equal to 10, right? Now what I can say, 10 is, right? Since I've used multiplication, what is the word I'm using? 10 is 2 times of 5. Can I say like that? 10 is, Nandini Madam, am I right?
Yes, sir.
Right. See, I've used multiplication, madam. Since I am using multiplication, what word I am using, please understand.
Okay, sir.
10 is 2 times of 5. Right? 2 times of 5. Right. Okay. So now, right. See, for example, this one, right? Suppose, right? Okay. So now, okay. So my, for example, right? If it is one more thing, right? If this is 5 into 0.9, what will happen? This will be 4.5. Yes or no, madam? Hello, madam. Yes or no?
Sir.
Yes. When it is not simply okay. So this is
Point is not visible.
point, right? So this is okay. So
Going.
all right. So now this is okay.
Okay.
4.5 is 5 into 0.9 times of 5. Yes or no?
Yes, sir.
So now when I put a point, right, times, now you have understood times, right? So, okay. Now, when my this times value is 2, that is more than 1, this is increasing, right? When it is less than 1, this is decreasing. Right.
Yes, sir.
Suppose, right. So suppose let me put 5 into 1.1. This is what will happen. So this is equal to 0.5. So now this is a plus. Okay, this will increase. This is a minus. This is decreasing.
Yes, sir.
Right? Yes or no, madam?
Yes,
So
sir.
when I use multiplication, I should use the word times. Am I right, madam?
Yes, sir.
Yeah. Now, see, please understand. When my beta is negative, right? When my beta is negative, this value should come down, right? Yes or no? When this increases, this should come down, right? Right? So, but when it is negative, my exponential beta will be less than 1 point. Yes or no? When it is negative, these are all points, right? So now, see, when my beta is negative, this will be in point, right? So my value should come down. When my value will come down? Only when I multiply, right? This value will come down. Am I right?
Yes, sir.
Right? So when I multiply with these values, right? So that will come down, right? Yes or no?
Yes,
it is not one increase, this increase. No. It is now I have to tell, right? So what I have to tell? So for example, if it is 1.5, right? So my odds, this is odds, right? So my odds will increase by 1.5 times, right? Yes or no?
Yes, sir.
Multiplication, right? Only when I multiply, this will come down. When it is positive, when I multiply, this will go up. So when I use multiplication, I said this is okay 2 times of, right? When I multiply, we will use the term 2 times, right? So now, okay, so whenever to interpreting this one, we have to use the word times. Okay, so only for that I've explained this much.
Okay.
Okay, we should use the word times, yeah, symbol, right? So now this is arts, right? This is art. Now how I should write is, right? That's all, right? I should write, okay. So now that tells us, right, the first value, right? What is the first value? 5.4, right? For rank 1, 5.4. This is dummy variable, right? How to interpret? By comparing with the reference category, we should write, right? By comparing with the reference category, I should write. I should use the word times. This is odds ratio, right? So all these things you know. Now let me write. So this is 5.4. This is for rank 1, right? How I am writing. So only this sentence is important, right? So that tells that model predicts the odds of getting admission, right? My dependent variable is odds, right? Please remember my dependent variable is p divided by 1 plus p, right? 1 minus p. So that is the odds, right? Okay. So here also the exponential of beta. Now see that you should not forget this equation, first equation, right? So now this equation, right? So odds equal to, this is odds equal to e to the power. So now I am explaining with e to the e to the power x, right? I am using that e2. So this is equal to odds, right? Okay. So now how I am writing, all right? Right. So it tells that odds of getting my dependent variable increase 5.4 times. Okay, higher than rank 4, right? Comparison with the rank 4, right? Clear?
Yes, sir.
Right. Yes. So what we have to tell. So now by looking at this one, this is the interpretation. Yeah, we have to interpret with this one, right? How to write. So now my dependent variable odds. So now it is a category variable. So my odds of getting admission will increase 5.4 times, right? So for rank 1 when compared to rank 4. So the probability of, or the odds of getting increase, yeah, odds of getting admission will increase 5.4 times, right? More, okay, than rank 4. Okay, for rank 1, people who have studied in a rank 1 institution, right? So people who have studied in rank 1 institution, their odds of getting admission is 5.4 times more than the people who have studied in rank 4 institution. Okay, so that is what you need to know. That is the most important, right? So now if you understood and all matter is over, all okay. So okay, you have to use the times, my dependent variable odds, right? It is a reference based on reference category, this many times more, right? So if it is minus, that many times less, that many times less, automatically it will be lesser 0.9, right? Okay, so now, okay, so okay, some more thing I'm going to explain. Okay, some more thing I'm going to explain. Okay, now, okay, so same thing. Okay, whatever it is there, okay, in this it is taken. So I don't think no book explains this way, so listen carefully. So I've calculated and I am explaining, right? So now all these values I have taken here, 5.4, 1.2. So please, okay, so whatever I'm taking, I've taken from these values. So bold, all these things, right? Okay, so don't think the how sir has taken now. So this is okay, so this is whatever available beta, right? Whatever available beta, right? So now what is my equation? My equation is, okay, y equal to a plus bx, right? What is a? Minus 1.52. This is a constant a, right? So this is my beta for rank 1 institution, right? So for rank 2 institution, this is my a, this is my beta for rank 2. So for rank 3 institution, this is a, okay, so constant is a, this is the beta, right? Okay, so now, right, so now e to the power, see now a plus bx. Okay, what is a? This is same, bx is a constant, bx is 0, right? So for a rank 1 institution, a is rank 1 institution, R1 is a, that is minus 1.522 plus beta 1.687 into 1, because for that variable rank 1, okay, we might have put 1 for rank 1 institution, all other 0, so 1. So minus 1.522 plus 1.678 into 1, which is equal to 0.165, that I have written. For rank 2 institution, A is same, minus 1 point this one, then beta into 1. For beta, the rank 2 institution 1, right? So rank 3 institution, like that, I should have written. Then, okay, so I might have got this 2, I written, right? For rank 4 institution, we might have put 0, that is why this one, right? Very good, not necessary. Okay, so now this is over. Next is, this is also I am calculated. This I have calculated. Now e to the power this value, right? So e of this is my e of a plus bx. So let me now a plus bx value I have, substitute e of this one, then I am getting this value. E of this one is this value, right? So that, okay, so that I explained in the next one, right? So now R1 is, it is written here, R1 is 0.165, e to the power 0.165 is 1.1793, R2 is e to the power 0.5 minus point. So when it is minus, this will be less than 1, so it is there, right? 1 over, right? Now, all right. So now this is my, okay, e to the power, right? So e to the power means odds, right? So probability divided by 1 minus power, that is the, whenever you put e to the power, that is the odds, right? So now this is my odds, right? Odds. Now, what is the probability? Okay, so what is the probability that I will demonstrate? Then, okay, so I will come back to this. So now remember this one, right? My probability is, right, r divided by 1 plus r. Okay, e to the power a plus bx divided by 1 plus e to the power a plus ex, right? So now, okay, we have already found e to the power a plus bx, all we have, right? So all we have, right? So now we have, okay, all. So this is the e to the power, right? So now I'm going to find out the probability of getting admission who have studied in this institution. So e to the power a plus bx, that is the odds, divided by 1 minus 1.179 divided by 1 plus odd. So which is equal to 2.179, which is equal to 0.541. That is calculated. So the probability of getting admission who have studied in R1 is 0.54. Like the same, second one, so 0.557 divided by 1.57557, which is equal to 3. So like that, okay, done. Okay, 0.587 divided by 1.5. So this one, right? So this is the probability, right? Note down the probability. 54, 35, 23. Okay, so this is 70, right? Right. Okay. So now we have calculated, right? We have calculated what is the probability of getting admission, right? Okay, now we will verify probability of getting admission. We will verify, right? Okay, so this I'm going to verify. Other things I will come later. Other things I will come later. Only 2 more points. Huh? Descriptive statistics, cross tabulation, right? Admitted in the row, you put admitted into the row, right? So the rank into the 4, right? We'll put the column percentage, right? Column percentage, right? Cells, column percentage, right? Rank 1. So now this is 16. Okay, so admitted, right? So here is admission rank 1, right? 45.9, 54.1, right? So I should get 49.1. So which is so here it will say PGR, right? Percentage within rank only. Okay, so percentage within. So 54. Okay. Rank. I'll go through. I'll go through. So this is the output. Okay, so I should see. Okay, so rank 1. Within rank. Okay, sorry. Percentage. Okay, so now you can see, right? So admitted rank 1 institution, right? My screen is visible. Hello?
Yes,
Hello?
sir. Yes, sir. Yes,
Yeah.
sir.
Now what I have done is, okay, let me perform again so that you will see, right? So now analyze, cross descriptive statistics, cross tabulation, rank in the row, right? And admit, that is our dependent variable, right, into the column, right? Then cells, row percentage. First I put column percentage, that is row percentage. Now you can see the important thing, right? So admitted, what is the percentage of rightly admitted? 54.1. Yes or no? Percentage of right admitted,
Yes,
right?
sir.
From the rank institution, from the rank people who have studied in the rank institution, what is the probable percentage? 54.1. So can we say the probability is 54.1%? Yes or no?
Yes, sir.
Yes or no? See, for the rank institution 35, rank 3 is 23, rank 17. Now let us look at this, our whatever we have calculated, right? So whatever we have calculated is, right? See, 54, all right, percentage of probability of 54, 35, 23, 17, right? So we can find out what is the probability of the people who have studied from the rank 1 institution. The probability of getting admission is 54. What is the, how you have calculated the probability? Odd divided by 1 plus odd, right? So this is what I have demonstrated there. This is what I have demonstrated here. I have written here, right? So now I have calculated here. Now by looking at the actual data also I have demonstrated, right? So this is over, right? This is over. Now finally, right? Finally, see, I said what based on this one, I said earlier, based on the E exponential beta of 5.4, 2.5, right? Okay, so this is what 5.4, what I said. So people who have studied in rank 1 is 5.4 times more than people who have studied in this one, right? That is what the probability of the people. Now look at here, look at it. So now see, this is the odds. Huh? So what is the, we said the odds is 5.4 times more, right? So what is the odds of rank 1 institution? 1.17, right? E to the power ax is the odd. So the odd of rank 1 institution is 1.17. Rank of, okay, so odds of the, okay, when beta is 0, it is 0.218. So 1.179 divided by, this is the rank 1, the odds, okay, e to the power odds of rank 1 institution is this one. So we are, what is the rank 4 institution? Alpha, right? The constant value will capture the rank 4 institution. So this is the constant value 21. So 1.17 divided by 0.218, which is equal to 5.4. So I can tell, right? So whenever see 10, right? What I am doing? 10 divided by 2, right? 10 divided by 2, which is equal to 5. So which means this is 5 times more than this one, right? See, what is this one, right? I will write. So when the value is 10, right? You know, but then I should be happy now, right? That is right. So now 10 divided by 2, right? Which is equal to 5. So I can say, so 10 is 5 times of 2. 10 is 5 times of 2. So now the odds of, okay, so this is odds of, right, rank 1 institution is 5.4 times more than the odds of rank 4 institution, right? So first top is rank 1 divided by rank 4, which is equal to 5.4. This is what here. Now we can see here. So this is the output, 5.4, right? So this is the calculated, right? So, right, this is the output, okay? So now this is the calculated value. Now here also we will calculate for this one. So rank 1 and rank 2 institution, what is the rank 2 institution? Okay, odds is 0.557 divided by 0.218. So 0.557 divided by 0.218, which is equal to 2.4. This is what calculated. This is the calculated value. This is the output value, whatever seen in the output, right? So that is why, right, we say 5.4 times. All right. So same result, we are used the word times. Now we are demonstrating time by using the time itself. Right. So this is the, okay, so this is the, okay, this is the, okay, so this is the output. This is the most important output, how to interpret, right? So now, okay, so right, so this we have done. After that we will not tell. So now finally let us take all the values, right? Like that you can calculate everything. And okay, so sorry, analyze regression, binary logistic regression. Let us put all, right, remaining also. So we'll put, okay, so how to run with all. Okay, so all, right, this is the category variable, right? We will go here, specify it is a rank, right? So now, okay, so always by exponential beta only you have to use the word times. You have to use the word times, right? If it is a category variable, okay, you should say the odds of, okay, odds of getting admission, dependent variable. So that is this many times more than this one, right? That is the word you have to use when it is a categorical variable. When it is a metric variable, right? When it is a metric variable, you have to write times only but not comparison with the reference category. Now, when there is a 1 unit increase in, that, okay, that score, right? So I will tell. So all other things you can see here, you can, okay, let us see dummy variables, right? Whether, so if you have noted down my earlier, right? So now 41 degrees, right? Earlier, okay. So if you see the earlier log likelihood, right? What is the log likelihood? So 41 minus, so it will come down, right? It will come down 458, right? If earlier, right? So for earlier, let us see the earlier log likelihood. $474, right? 474. If you reduce that value, you will get reduce, right? Reduce. Okay. So now here, okay. So now 71%. Okay. Whether it is significant or not, right? We will look at the reduction is significant. Okay. Pi square reduced by 41, significantly reduced. My R square might have improved, right? R square improved, okay, to, okay, point, the earlier 0.6 something, it has improved, okay. So my accuracy is 71%, right? So right to right, okay, so specificity, all you can write, okay, so you can write. Now variable in the institution, right? So now I have to tell, when compared to rank 4 institution, see the probability of getting admission, right? So it is 4 point, this not probability, odds will improve, right? My dependent variable is R, we are using exponential, right? So odds will improve by 4.71 times when compared to rank 4, right? So this you know. Now what you have to write here? So my odds, this is also plus, right? This is also plus, this is also plus. So when there is a 1 unit increase in the GRE score, right? GRE score, my odds will improve 1.002 times, right? So this one is when my cumulative curve percentage, when it increases by 1, so this will improve, the odds will improve, odds of getting admission will improve 2.235 times. Okay, so you can find out if you want to find out the percentage, you can find out. So e to the power, right, this is a constant, e to the power a plus bx, right? So you will get e to the power, right? So divided by 1 plus e to the power, then you will get that, okay, probability. So probability getting admission. So but you can, okay, you can find out by using the this row percentage also. So this is with respect to the binary logistic regression. Any doubt? Any doubt? This is very interesting. Hello, any doubt?
Anybody have any doubt, please raise your hand.
Hello, madam. Nandri, madam.
Sir, I am here, sir.
Okay, so can you able to understand something, madam?
Yes, sir.
No, voice is very, very feeble. Hello?
Yes, sir, I am here, sir.
I'm not able to understand that?
I understood, sir.
Yes, madam. So anybody not able to understand anything, if you are not able to understand, you please tell me.
Okay, Dr. Vivek Gupta, sir.
Yes, sir.
Good evening, sir.
Good evening, sir. Good evening, sir.
Good evening, sir. Am I audible, sir?
Yes, audible.
Sir, the today's session is a very, very informative and excellent session, but it is a bit technical because of, say, involvement of mathematics and all. So if when we get, this material, your PPTs and this thing, then I personally feel that I would be able to, I'll have to, have a second look on what you told at the moment, we are getting. But I think that when we get the material, I think that time a second look will give us.
No. Okay, it is not technical, sir. It is not at all technical. See, okay. We have to interpret, right? So all this interpretation is easy. By looking at this one, you can tell, right? See, for example, this is the first output. So our prediction improves, the chi-square is improved by this much, right? Otherwise, log likelihood decrease by this level. That's all. So when it is significant, our prediction has improved. Okay, significant. That's all. Matter over.
Yes, sir.
So now when you go to the another output, my R square is this much, right? So that is the second one.
Sir.
Third one, my prediction accuracy is 71%. Okay, so it is not at all required any understanding. Now only here
it has improved.
No, wait, sir. Now here only two things, right? Only what are the two things? When it is the category metric variable. So normally we will say when there is a 1 unit increase in this one, this will increase by this much. Now we are not telling it that way. Here what we are going to tell, when there is a 1 unit increase in this match, okay, so the odds of getting admission will improve this many times. That's all. That's all, sir.
Yes, sir.
No technical, sir. No technical, right? So now I have demonstrated in a technical way. That is why I said not necessary. The only that one single sentence is sufficient, right?
Yes, sir.
So now why, see, I have proved why we are telling times, right? I have proved how we say the probability. All I have proved everything. So now if it is a categorical variable, we have to tell odds will improve, right? Odds will improve when compared to reference category. That's all.
Yes, sir.
That's all.
Yes, sir. Yes,
so
sir.
This many, the bird is this many times, right?
Times.
Why we use times? Because we have to multiply. Because here here exponential beta will not be minus, right? So because beta, when beta is negative, exponential beta will be in point.
Right.
When when beta is positive, my exponential beta will be more than 1, right? Okay.
Yes, sir.
So then only when I multiply only, it will increase. When I multiply only, this will decrease. That is why when we multiply, we use the word times. That is what I explained.
Yes, sir.
So that I might have taken more words, but in case you have to use the word times.
Times. Yes, sir. Sir, thank you so much, sir. Thank you so much, sir. Thank you, sir.
See, the idea is, see, I've seen, okay, so my scholars and all, they used to refer, I'm not referring much. So they used to tell, they will write this times all these things, right? I know it is a multiplication, that is why it times, right? But the odds, all these things, I was having little this one. When I calculated like this, then I understood it is nothing. Yeah, okay, it is nothing. That is why, okay, if you understand this technical part, then you will realize how it is done, how it is calculated, right? So that is why I am doing, sir. So no book will tell this one, sir. No book will tell.
Next is Gnanachandran.
See, one Vivek Gupta sir is not understanding, others will have serious difficulties. Okay, others, please ask, sir. Yeah.
Gnanachandran, sir.
Hello?
Yes, sir.
Sir.
Yes, sir.
Hello, sir.
Yes, sir.
Sir, my doubt is that there are some papers, sir, in others, interpret the beta coefficient and create the equation based on the beta coefficient. And but most of the papers describe the based on the odds ratio. Odds ratio is most meaningful, but beta coefficient is need not for interpretation or
No, sir. No. Don't use beta, sir. Right? When you use beta, sir, right? My dependent variable is log of odds, sir. Right? See, logs itself difficult to understand, right? See, when you use beta, sir, right? Then look at my dependent variable. My dependent variable is ln of odds.
Admission.
Yes or no, sir? See here,
Yes,
when I
sir.
use a symbol beta and a, my dependent variable is log of odds, sir, right? So can you understand what is log of odds?
Yes, sir. Yes, I got it. Thank you, sir.
You will not understand, sir. So that is why, okay, so use with the exponential, sir. Yes or no, sir?
Yes, sir. Yes. Thank you, sir. Thank you.
The exponential is nothing but the exponential of beta symbol. That's all, sir. But it will become odds. Yes. Anything else? So I thought of completing the cluster and the other things. So, okay, anyhow, time's up. No doubt, huh?
No doubt, sir.
Shall we stop or let me take up one more technique, madam? Madam?
Sir.
So shall I take up one more technique or shall we stop?
Okay, sir, you can take.
Hello?
Yes, sir, you can take, sir.
Okay. So now I think, okay, so this will stop. Okay. So now, okay, thank you very much for all your patient listening. Okay. So already I've shared all the material to Sivakumar sir. So he will send, okay. So how he is going to send, whether he will put it in, I think, because I've sent, okay, as a different file. For chi-square, I've sent one mail. ANOVA, I've put a separate mail. Okay, so like that, I put a separate mail. Okay, so then, okay, so Nandini madam, please download each mail separately and create a one folder for it. Right?
Okay, sir.
If you put all, people will be confused.
Okay, sir.
For every mail, download, put it in one folder, chi-square folder, then ANOVA folder, like that. Then you zip it and send it, right, madam? So if you send all together, save all together, zip it, people will be too much confused.
I can do the same to see.
So which data meant for what? All there will be a confusion.
Sarita madam, yes, ma'am.
Now, any questions you can ask, sir.
Sarita ma'am.
Yes. Good evening, sir.
Good evening, madam.
Thank you for the wonderful session, sir. Is it possible to share your email ID if we have any doubts and further after practicing, whereby we can contact you, sir, or further FDPB where we are planning to organize in our college where we can contact you? Is there anything of that kind, sir?
Yes, madam, yesterday, no, madam, you are, why this much explanation not necessary, right? Yesterday, whether you have attended, madam?
Yes, sir, I attended.
Yesterday or tape for yesterday, I have given, madam, in the open, this one I have given.
Oh.
You are not, yeah. I think you are not, okay, so now, so I will tell again, I will write it here, right? Okay. So now,
yes, sir. Thank you, sir.
So my name is...
but personally, I learned SPSS from you, sir. Rather than from the books, I registered for Udemy also, but I was not able to learn what I have learned from here, actually.
Yes, madam.
Actually, I registered in Udemy also, sir, udemy.com, where I bought a course and did. But then too, I didn't learn much. But all these 10 days, I was able to learn something in spite of my household chores and etc. So for that, I need to
My
pay a
name
big
is
thank you.
Kasilingam, right? KASI. So Sivakumar sir will put SH, not SH. So, okay, so DMS. DMS means Department of Kasilingam, KASI. Okay, so KASI, LINGAM dot, here dot you have DMS at gmail.com. Hello?
Yes, sir.
Yeah. So my mail ID is written. It is visible or not, madam?
Visible, sir. Visible.
Yeah.
Visible, sir.
Kasilingam dot is missing, madam. Okay. So
Dot is missing, sir.
dot I am putting, but it is going away. Dot.
Yes. Doing something.
DMS means Department of Management Studies at gmail.com. Any other thing?
Rohini ma'am, photo session is over.
No, sir, not yet, sir.
Not right. So any, okay. So now you can ask any doubt. Okay. So I will take up 1 or 2 questions. Anything you can ask.
All participants tomorrow onwards missing our group.
So now any doubts, sir, any whatever the doubt they have, let them ask.
Today is open option, but every day we are mute for all participants. Today, any doubts, please ask me your doubts. Sir is available. No, sir. I think
No doubt, huh?
Sir, no. No, sir. Oh my God. Okay, Anita ma'am. Okay. Anita ma'am.
Like
Anita.
Simran Singh.
Simran Singh.
Hello.
Yes.
First of all, I would like to thank you so much, sir, because it was really a wonderful session and I have learned so many things with so much fun and I enjoyed it a lot. But so actually my question is not from SPSS. It's a little bit of practical question. What if you get, you are not comfortable and you are not happy with a supervisor, like you are feeling that my supervisor is not guiding me a good way and I'm not satisfied. In that condition, what should I do?
No. See, no. The point is very, very simple, madam. Supervisors, they do not know. If they are not guiding you, you are blessed.
How, sir?
Yes. See, what happened, I will tell you. See, when I was making a present, my Vivasi presentation, so my Vivasi examiner from Kottayam University, director Sri Ranganathan, he was my examiner. So people have asked the questions. So at that time, my guide was started answering. Then the examiner said, so, sir, no, sir, let him answer, sir. Okay. So then I was answering, it was going on. Then after coming out, he has told me, sir, see, you are answering well. If I have allowed your guide to answer, he might have given answer on his own. Then he might have given wrong answer also. Then you have to defend your guide. You cannot tell something different from what guide has stated. So then you will be in a different situation, right? If they are not guiding, it is a blessing in disguise. Okay, whatever you want to do, you can do, right? There are a lot of materials available in the internet. Okay, so you can do wonder. So you can do whatever you want. Okay, so with respect to see one idea which I can tell is, so collect review as much as possible, right? Then okay, so put it into some place or some software. Otherwise, find out what are all the variables they have studied, right? From that, you choose some variable for your study. Then based on the relationship, you put a conceptual model. Conceptual model is one independent variable, dependent variable, right? That is the conceptual model. For each variable, put the questionnaire, right? Give that questionnaire to some experts, get them validated, and go for data collection. Go for data collection. So probably Sivakumar sir might conduct one Amos workshop next time. So you
Sure, sir.
attend that workshop.
Sure, sir. 100%.
Okay, you attend that workshop, all right, because that is more important, more relevant. Attend that workshop, easy. That's all matter over. Very, very easy. Life is very easy, madam.
Anita, ma'am. Next question.
Yes, sir. Good evening, sir.
Good evening, madam.
Sir,
Yes, ma'am. You proceed your question.
sir. Sir, with respect to the questionnaire, that is demographic profile age, sir, you told like you need not to categorize, you just give an open-end question. What is the difference between open-ended and categorize? If I give categorical, if I categorize the age, I can analyze even using the categories, isn't it, sir? Or I should only give open-ended question for age and income. Day one, you told like you just give an open-ended question for age and income.
No, madam, I will not say like that, madam. See, it is up to you. For example, income, right? I have collected in a metric form. But if you feel, okay, people will not give their exact income, okay, but they will be easy to take, you give them, right? Based on that, okay, so no confusion, right? So now, when you have given as a categorical variable, right? You can use with another categorical variable as a chi-square. You can use with other metric variable as a ANOVA and other things, right? But if you are used as a metric variable, that is dash, then that is a metric variable, right? If you want, you can convert into categorical variable, right? See, I will tell how to convert, right? So you can convert into categorical variable, okay? You can use, if you want metric variable, use that. If you want categorical variable, use this one, this category, what you have converted. So metric variable can be converted into category, but category variable cannot be converted into metric, not possible. So that is why, if possible, try to collect data in a metric form. Metric form. So you can use many techniques, the regression, anything you can use only when your data is metric. Okay, it can convert into category also very, very easily without any difficulty, right? So I will tell how it can be converted. Okay, so one data I will take. So now let us take this variable. Now here, okay, age of the employer I have collected as a metric, right? 52, 41, right? So now, see, for example, right now, I find out descending order something. Then, okay, so then what I will do is, so now, see, for example, 26 to 35. Okay.
Excuse me, sir.
Not
Sir, only, sir, not the main.
Not sir, not sir. I will show. Okay, I will show now. (26 to 35, 36 to 45, 46 to 60. Okay, so now, see, for example, I have one variable like this, age. Since you have asked age, I am so now this is a metric variable, what actually is. So now I want to convert to category. Now transform, right? Recode into different variable. Why different variable? Because already sometimes I might record this variable also, right? Right. So if I want that, I can use it. Okay. So let me save as a different variable. So transform, recode into different variable, right? Then, okay, age, what is the variable you want to take? Okay, age, old and new. Okay, here, if the old variable is, okay, if the old variable is, okay, less than or less than greater than also use, you can use. If it is less than, okay, let me put less than, right? So 35, right? Let me put. Okay. So less than 30, lowest to, sorry, lowest to less than 35. So new category is 1, right? Add, right? Second one, if old is right, 36 to 45, right? So now my new value is 2, right? Add. If my old value is highest, right? So which means more than 45. Let me put 3 here. Okay. So now if I add here, the value will not come. Okay, because I'm not given new, because I created a new name. So let me give a new name, right? So let me put a re-age, some REH, some new names I have to do. So re-age, change. Okay, then okay will come. Okay, so now you can see here. We can see in this one, new variable is created. New variable is created, right? So now in the values, right, you write, okay, one is okay, less than, right, less than 35, right? 2 is, so whatever you want, you can put less than 36, okay, anything, whatever you feel like. Okay, 36 to 45. 3 is okay, more than 45, like that you want to put. So to create, okay, it can be done, right? Can be done. So now you can go, if you go and see, you can see here. Okay, so here like this. Here, so you can see here, right? All are there. So this can be converted. Now, suppose, see, for example, yesterday I went to Karikudi University. I was conducting some Vivas examination for one scholar. So, okay, when the mean value for male is less, more, okay, a mean value is more less, but female mean value is more. But as he was telling, there is a gender gap. So mean male is having less. Hey, what is this? The mean value is more, but you are selling lesser. Then she was telling, sir, I used to strongly agree once, sir. Okay, strongly disagree 5, sir. So that is why when the mean value is less, which mean value more, I have to sell less. Right? This you will tell, but the reader may not understand. You convert it, right? See how to convert it. For example, if it is a 5-point scale, right? So 2, 3, 4 like this. Okay, 1, 2. So 5-point scale like this. See, wrongly you have put 1 as, okay. So I have to convert this into right, same variable, not a new. So what I have to do is, transform, transform, recode into same variable, right? That this variable, let me take. So okay, so old new. So old is when it is 1, new variable is 5. And when the old is 2, new is 4. When the old variable is 3, not necessary. When the old is 4, this should be 2. When the variable is 5, this should be 1. Right. So now if we go and see, so now we have put 1, 2, 3, 4, 5. Now you can see 5, 4, 3 like that. You can see 5, 4, 3, 1. So it will be changed automatically. No, so this can be done. If it is 1, I put, you can put any number of variables at one stroke, you can put it. Okay. So now if you want to have some, for example, missing value, I want to convert missing value as a 0, right? Okay. So now here, so this missing value as a 0, right? So then transform. Okay. So recode into same variable. So now this are all, let me remove. Otherwise, it will be done again. Okay. So now here, when it is system missing, right? System missing. So I have to put a new value as 0. When the old value is system missing, now, okay. If you continue, right? If you say okay, so now all the values you can see 0, right? All are 0. Right. So like this, you can do any conversion, you can do anything. So if necessary, you can convert to category. If you want that, you can use. That is why, right? So, but converting the age you can put, right? So experience, education, how to convert. So number of years of study you can put. Number of years of study you can put. Then that will be a metric variable. That will be a metric variable. Okay, years of experience dash. Okay, so like that. Right, madam? Right. Okay, so okay, madam, understood that?
Yes.
Yes,
Madam,
sir, I'm here, sir.
not Nandini, madam. The person who has asked question.
Okay. Sumita, ma'am.
Okay.
Yes. Okay. So any other query, madam? Two
Yes,
participants raised hand. Two
Sir,
participants.
sir, thank you, sir. I understood, sir. The one who asked out, Anita.
Yes,
sir.
yes.
Thank you so much, sir.
Thank you, madam. Thank you. Thank you.
Thank you so much. Sir. Thank you.
Sumita, ma'am.
Sir,
Sumita
can you
P.
hear me? Sir, can you hear me, sir?
Yes, madam. Yes.
Sir, I have entered my data in Excel sheet, sir. Can I take the Excel sheet into SPSS, download Excel sheet to SPSS? Is it possible,
Yes,
sir?
yes. Here, file. Okay. Import. Okay. Go to Excel. Okay. So import. Right. Excel file can be imported. Right. By using this one. So Excel file will come here.
Okay, sir.
Sir, this is time to photo session, sir.
Yes, sir.
Photo session. Photo session, sir.
Oh,
Sir,
Yes.
wait, sir. Wait,
sir,
sir.
one small doubt, sir.
Yes, sir.
Sir, this is Sindhil Kenathan from Hallmark, sir.
Oh, sir.
Good evening, sir. Good evening, sir.
Yes, sir. Yes, sir. Yes, sir.
Sir, first of all, I need to thank yourself and the organizers, sir. Definitely, chanceless session, sir. I attended so many sessions, but this is the top class. I learned two things, sir. One is SVSS, and the other one is the way to teach the students. No, really, right? I've taken you as one of the role models, and I've started the way you are doing it for SPSS to my students. I've already started,
Thank you,
right?
sir. Thank you.
And really, I'm getting a very good response in that manner. So I need to thank you personally and through this forum also. That is one thing, sir. Sir, and one small, it might be a very small doubt also. Sir, regarding the missing data, is there any way that, so I didn't attend that first session, sir, so I don't know whether it was covered or
No, no problem. Tell, sir. Tell.
See, the thing is, in missing data, there are so many ways to fill the data. For example, is that with the mean, is it possible to fill it, or any other ways to fill the missing data? Sir?
No, sir. See, the idea is right. So when you have a missing data, sir, right? So, but missing data should not be there if you want to fill.
Yes, sir.
Then you, if it is a metric variable, right? If it is a metric variable, so fill with the mean, sir. Right?
Mean, okay, sir. Right,
Fill
sir.
with mean. If it is a ordinal variable, right?
Okay.
Fill with the median. If it is a nominal variable, fill with the mode, sir.
Mode. Okay. Okay. Sir. Right. 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 Okay, sir. Because I have heard it, but I don't know. That's what I just wanted to check with you.
Yes, sir. Correct.
Right, sir, right, sir.
Then
Right,
your
sir.
result will not be distracted, sir. By
Correct. 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 Correct.
So one more thing, sir. See, here. Okay. So now I will go back and I will say, right. Transform. Let me do transform again. Transform into same variable, right? So old new, right? So if it is if old one is 0, right? Old one
Okay.
is 0. Old one is no. I am doing something different, sir. Okay.
Okay.
So now when old one is 0, old one is 0, right? Old one is 0. New one is system missing, right? New.
Yes, sir.
So if you have already 0, now I want to make it as missing, right?
Correct.
Now all will be missing value, sir. All will be missing value, right? All will be missing value. Now, so instead of missing value, right, I want to show this as a, okay, there is a if condition and all you can do, right? If missing value is this one, fill with mean, all you can do. I'm not telling, right? Now here, when I have created a variable view, here also there is a missing, right? So
Okay.
now here if you put, see, okay, so already I have values up to 5, right? So I can put, okay, if I put here 6, so all missing value, it will be 6.
Correct. Okay. Okay, sir. Right, sir.
All missing value will be 6.
Okay. Okay.
Okay, so now, okay, so I have not saved that. So that will be filled with that value, sir. That also, or you can put a 6 or 7, 8, which means 3 value, right? So now, for example, if I put a 6, right? Let me put 6, okay, let me put 6, right? See, okay, only I have values up to 10. Only I have values up to 10. So I have remaining values missing value, right? So this 6 also will be considered. See, only I have value up to 10, right? So remaining value, let me do the frequency analysis. Let me do the frequency analysis. So let me take up this one, right? Let me take up this one, right? Let me take up this one. So let me say frequency. Now the 6 also will be considered as missing. See here. So up to 5, this one, 6 also considered as missing. So this is system missing means not filled. Okay, by giving some value that you have put as a missing. That is the use of that missing, sir. But you have to use if condition to fill up this one. Otherwise, you have to go each one and you have to fill some. Hello? Hello?
Yes, sir.
Yes. Okay, madam, we will stop. Any other question? Otherwise, we will stop, madam.
ಶಿವಕುಮಾರ್ ಸರ್ ಮ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡಿದ್ದೀರಾ?
Shivkumar sir, please unmute sir.
ಶಿವಕುಮಾರ್ ಸರ್. Yes,
Participants,
sir.
please, it's time for photo session. Please on your video. We record all. I request all the participants to on your video.
Webcam.
I request all the participants just for 1 minute. With sir, it's a great opportunity.
See, my video is visible, sir.
Yes, sir. Yes, sir. Super, sir. Okay, everyone. Oh, thank you very much. Thank you, participants. Second slide is over.
Okay, so Tilaga madam, I could see. Thank you, madam. Thank you.
Okay. In third slide, please on your video. I request everyone, please. Just last in 2 minutes, we conclude this session. Please on your videos. It's recording.
No.
Yes.
If you are not, they are not ready, you need not do, sir. Okay. If they are willing, you can do, sir. Because it is night time, sir. So some girls will be some girls will be nighties and other things, sir.
Okay. Sorry, sir. And last fourth one. Okay, over.
No, I am in the office, sir. No problem. Okay.
Okay, ma'am.
No, Nandini madam, I have not seen her. So
Nandini ma'am. Ma'am, sir, Nandini ma'am is ready to join as a research scholar in your university.
Sir, I personally heartfelt thanks to you, sir. Even I was zero before attending your session. Now I learned something from you, that too SPSS, sir. I would like to join your offline program, sir.
So that will be more riskier. I will make everybody to work. That is the everybody should work, sir, when you come.
Okay, Rohini ma'am, please conclude it. Sorry, Nandini ma'am, out of time.
Yes, sir. Okay. So I request Nandini ma'am to present the vote of thanks. Nandini ma'am, over to you.
Once again, it's a great opportunity for me to render vote of thanks for this 10 days national level faculty development program. Completely successfully, we are done with the 10 days faculty development program. This credit goes to organizers. At the same time, equally, this credit goes to our resource person. I heartfelt thank to Dr. R. Kasilingam sir on behalf of me as well as Seshadripuram Academy of Business Studies for joining with us, for providing and enriching our knowledge towards SPSS. Thank you so much, sir.
Thank you, madam. Thank you. Thank you, everybody. Thank you all people. So through this platform, I met around 500 people. Thank you, Mr. Sivakumar, sir. So you have made some more people as friend to me. So see, I feel when you have more and more relationship, that is the asset. So okay, so that opportunity you are given. So not only in India, throughout India, and but also some abroad, some people have come. So you have taken my legacy and this thing too, other this thing also. So thank you, Mr. Sivakumar sir. Already I've done 5 days. So you do for Amos and other things, sir, for 5 days or 6 days.
Sir, offline,
Sure,
sir.
sir. Offline, sir.
Sir, please, offline, sir.
No, offline. Online is very good because offline I have to come and other things. Okay, so offline, online I need not apply for leave and other things, no, madam.
Okay, sir.
Yes,
Okay.
that is the advantage. Any time is not a issue. Time at any time you can do, but if it is online, it is easy. Offline means so more than 3 days I will be under trouble, right? But now we have a vacation time, no issue. Vacation time, we can do it.
Okay.
We collect your data. Whenever you free, we ready to.
Okay, sir. Okay.
I also once again thank Shivkumar sir, who is our research coordinator, for organizing such a wonderful program for us. Thank you, sir. I also thank our Professor Jairam sir for supporting in order to conduct this program, and also our HOD Soumya madam, Department of Commerce and Management, and IQC
Thank you, ma'am.
Chaitanya. Thank you, ma'am. Our coordinator, IQC coordinator Chaitanya ma'am, and all my dear colleagues, especially who were in the technical team in order to conduct this kind of every day's, each day's technical support especially. Thank you each and everyone who is directly or indirectly supported to organizing this program. And dear participants, dear teachers, one who participated for entire 10 days FDP program. Because of you, we successfully completed 10 days faculty development program. Thank you one and all.
The Nagalakshmi madam is raising the hand. And
Okay, if anybody, okay, sir, this session is over. If anybody want to interact with us, sir, you can stay here. Otherwise, you can leave. Thank you very much.
Okay, now my request to all, the success of this program depends upon how many people they use it or in their guiding and in their writing the paper, right? Simply coming and going, it is no use, right? Use it, right? So now one day I was there in the I was there in the Saravana store.